Welcome to Homework Lib.
Hi, so in this case what we have is a momentum conservation problem where we know that the initial momentum needs to be equal to the final momentum. So initially the momentum is equal to mass 1, velocity of 1 plus m2, velocity of 2 at the beginning. They are standing, both of them, at in rest, so that means that we have an initial momentum equal to 0, and the final momentum is going to be mass of 1, velocity of 1 final plus mass of 2, velocity of 2 final. Okay. Since this needs to be equal to 0, we know that mass 1, velocity 1 final needs to be equal to minus m2, velocity of 2 final. Now we simply need to put the values over here. So mass 1, it is going to be equal to 55 kilograms. Mass 2, it is going to be equal to 95 kilograms. So, for example, if we solve for velocity of 1, we're going to get that is equal to minus 95 over 55 times the velocity of 2. Remember that 2 is the person with 95 kilograms of mass. So this tells us that the person with the higher speed is the person with a mass equal to 55 kilograms. Because the factor that we have here is larger than 1. Similarly, if you want to solve for final velocity of 2, you would get 55 divided by 95 times the initial velocity, the final velocity of 1 with a minus in front of it, right? So this factor is lower than 1, and we know that object 2 or person 2 is going to move slower than person 1. So this is going to be your final answer. The person with the lower mass, it is going to be moving with a higher speed because of the conservation of momentum. And that is all. Thanks.